All right, this example is sort of a simplified model of an insurance company. They classify drivers into two categories. One is the category of people who had a wreck in the previous year, and those who have not had a wreck in the previous year. So I'm making this where it's like each calendar year. That way we have a nice defined place of where people change from one category to another. So they determined that a driver in N has a 90% chance of staying there for the next year and a 10% chance of moving to W. And if a driver's in W, they have an 80% chance of moving to N and a 20% chance of staying in W. So we've got the diagram here, and I want to write out the matrix. So, well, first let's read. What are they asking us to do? Suppose initially 80% of the drivers are in N and 20% are in W. Find the distribution for the next 3 years and then find the steady state. Before we do that, let's look at this thing for a moment. Notice coming out of N, the totals are 100%, and coming out of W, the totals are 100%. But the totals going in can vary quite a bit. Notice how much is coming into N. Well, we've got 90% of these and 80% of these. And how many are coming into W? 20% of these and 10% of these. So you would expect over time for N to have a lot more people in it than W. So let's see. It says find the distributions for the next 3 years and then find the steady state. All right, so our P matrix in this case, P is called our transition matrix. A lot of books call it T. I'm not sure why this book calls it P, maybe for probability. But I find it useful to label my thing here. N and W. And remember, this is from, this over here is to. So if you're going from N, right here is going from N to N. So that's going to be 0.9. And then from N to W is 0.1. I find it easiest to do these column by column. That way we know that the sums have to be 1. So 0.9 plus 0.1 gives you 1. Okay, this right here is people who go from W to N. That's going to be 80% or 0.8. And then going from W to W, that's 0.2. So this is our P matrix. And let's see, what do they tell us? 80% of drivers are initially in N. Yeah. So our X1 here is 80-20. So it says for the next 3 years. Let's do that on Octave. I don't know if I'm even going to really copy it down over there. All right. So I've got to put in my new P matrix. P equals 0.9, 0.8, 0.1, 0.2. And I don't know if I've shown you this before, but if you type in sum and then put in a matrix, it'll give you the column sums. So that's a good, quick way to check. If you wanted to do the row sums, the thing to do there would just be sum of the transpose of P. But the row sum, the column sums is what we care about, and those both sum to 1. All right, so our X1 in this case is 0.8, 0.2. So our P1 is, or not P1, X1 is our starting amount. Sometimes people start with X0, but X1 is that. X2 then is 0.88 and 0.12. X3 is going to be this 0.888, 0.112, and X4, I think I see a pattern developing. Yeah, 0.8888, 0.1112, and find the steady state. Okay, let's do the steady state 2 different ways. First off, I'm just going to raise this to a huge power. And notice we get this. I'm going to change that to format rational. And so the steady state is 8/9, 1/9. So eventually this will converge to 8/9 of the people being in N, and 1/9 of the people being in W. And of course, that doesn't mean it becomes static after a while. It means people are still kind of moving back and forth, but 90 or 8/9 of them will be in N, and 1/9 of them will be in W.